pleasure for me to introduce Dr. Dennis Ebbetts of Ball Aerospace and Technologies Corp., headquartered in Boulder, Colorado. Dennis is the business development manager of Ball for NASA Aerophysics missions. He's worked on the Hubble Space Telescope and numerous other space science missions. These have included the James Webb Space Telescope and the Terrestrial Planet Finder. He has the academic credentials, the relationships, and the management and communication skills to carry out his responsibilities. What's more, he enjoys communicating the Ball Aerospace story and the scientific results of NASA programs to the public. That's us. It's fitting that we hear about aerospace during our centennial year. Colorado also has a rich air and space history. On the air side, the first Coloradoan to fly an airplane did so in January 1911, the same year our club was formed. Fellow Rotarian L. Ray Jepson, in his barnstorming days, began making notes on the routes he was flying. Those notes and the man behind them became the leading provider of aeronautic charts to the world. On the space side, the story is just as rich. 6 astronauts have come from Colorado. Numerous rockets and their payloads have been built here. Martin, for example, built the first Mars probe here. Ball had 7 Earth-orbiting solar observing satellites in the 1960s. And all of the instruments on the Hubble were made or fixed by Ball, which brings me back to our speaker today. Please give a warm welcome to Colorado business builder, Dr. Dennis Ebbetts.
Okay, thank you so much, Don. Very flattering introduction. This is actually the 3rd time I've visited this club, as some of you have been members for a while. I actually have been here twice before. I'm sorry? A little closer? Is it? You're hearing me okay? Okay, very good. Well, as I said, this is, I think, the 3rd time that I've been invited here, so I'm very delighted to be with you all again. And the theme, I guess, is a little bit about aerospace, or the history of aerospace in Colorado. I have been myself at Ball Aerospace up in Boulder for 26 years now, and I've done talks like this over the years, so I have a little bit of insights into the company. I'm very pleased to have several of my colleagues from Ball Aerospace and Ball Corporation here with us today. So, we are at Ball Aerospace and Technologies Corporation. We are, in fact, a subsidiary of the larger Ball Corporation, whose headquarters are in Broomfield, about halfway between Boulder and here in Denver. The Ball Brothers Glass Manufacturing Company actually dates back 130 years or so, back into the 1880s. The founding 5 Ball brothers there, and we are the company that was known for the mason jars, for the glass ball jars for many, many years. Today, the Ball Corporation is a large company. It was a family business for many years, but today it's a Fortune 500 company, and annual revenues exceed about $7 billion. We were founded in the mid-1950s, 1956, by Ed Ball, who was one of the sons of one of the founding Ball brothers there, and he started us as a small company in Boulder. We were called Ball Brothers Research Corporation for many, many years, and part of the intention was that we would provide some R&D type services to the glass business. There was a wonderful story. I actually had the pleasure of knowing Mr. Ball. I had met him several times while he was still with us. And he had stories about his service in the Army Air Corps in Italy during World War II. And they said there were 2 realizations there that motivated him. One was that the technology, the science and everything, the technological superiority and its importance to the war effort. And the second thing was visiting museums and things in Italy. He came to realize that he didn't know much more about making glass or how glass worked than the Romans had 2,000 years earlier. And he was determined then to put the whole glass-making business on a more scientifically sound footing, and that was one of the motivations for forming the Ball Brothers Research Corporation. Anyway, today we are about 2,800 employees or so. Very well-educated workforce. Our annual revenues are on the order of $700 million. We are mostly, about 2/3 of the people are on our facility in Boulder, and we also have a facility on the Broomfield campus and a few other places around the country. Most of the work, I am a scientist by training, an astronomer, and I have spent my entire career working on astrophysics missions. So if this talk seems a little astrocentric, forgive me, but that's what I know about, and that's what I've done. Our primary science work is done in what's called the Civil and Operational Space Strategic Business Unit, and SBU is one layer of organization within the company there. We work on fields such as weather and environment, basically earth science. Let me see if this pointer works. Oh, yes. Solar system exploration. We have had instruments on Mars, at Mars now, as a matter of fact. We do a lot of astrophysics stuff. That's where I am. Solar and heliophysics, a little bit, not too much. A little bit in human exploration, and a small but growing component of our business in international programs. Our largest customers in these areas, NASA and NOAA. NOAA is the National Oceanic and Atmospheric Administration. We work with many, many universities. Most of our science missions are connected with scientists at various research universities. We also do work for the larger primes, Lockheed Martin, Northrop Grumman, Boeing, other big companies like that. And there are a number of commercial companies. Digital Globe, for example, in Longmont is a commercial company for whom we build a lot of space hardware. Okay. For space science missions, the types of things that we do, we are a hardware company. Okay, we do some engineering services, but primarily what we do is design and build flight hardware. And this can be the focal plane arrays, which are the detectors that are the light sensing elements. We build this is one of the focal planes that's on the Hubble Space Telescope right now. The electromechanical systems, this is a mechanical system that points cameras in the right direction, and there are two of these, one on Spirit and one on Opportunity, the two Mars rovers that have been working on Mars for the last few years. We build a lot of optical systems. This is an instrument, this is an optical camera that is on the Mars Reconnaissance Orbiter that is currently in orbit around the planet Mars and taking the highest resolution images of the surface of Mars ever taken. This is one of the Hubble scientific instruments. We built 7 of these guys over the years. This was a cryogenic infrared telescope for an observatory called the Spitzer Space Telescope, and this was one of the highest performing infrared telescopes that astronomers had ever had access to. And we do a lot of operations and flight software and things like that. So our instruments have enabled some tremendous breakthroughs at least in the areas of astrophysics where I've been involved. We built an instrument on what was called the Compton Gamma Ray Observatory. It was kind of a companion to the Hubble Space Telescope, but working in gamma rays. And it discovered evidence for the annihilation of matter and antimatter in the center of our galaxy, and that was pretty interesting. The Cosmic Background Explorer was a satellite that we built many years ago. Actually, it was launched in the late 1980s, and its job was to measure the microwave cosmic background radiation, for which its 2 primary scientists won the Nobel Prize in Physics about 5 years ago. That was very exciting. And one of our Hubble instruments, called STIS, the Space Telescope Imaging Spectrograph, obtained data that confirmed the existence of what are called supermassive black holes in the centers of many galaxies. So that was very interesting. Our imagers, we've built a bunch of very high-quality imagers in the ultraviolet, in the visible, and in the infrared part of the spectrum, and some of the iconic photographs, the images that the Hubble has taken of the universe have been taken with our cameras, which we are very proud of. Some of the planet images taken in the ultraviolet, I think, are particularly cool. This is obviously the planet Saturn, taken in ultraviolet light, in reflected solar ultraviolet. The disk of the planet and the rings are not terribly interesting, but what is interesting is you see the aurora, that Saturn, like Jupiter, like Earth, and that's about all, like Uranus and Neptune to some extent, but all the planets that have magnetic fields interact with the solar wind and show this phenomenon called the aurora, which is not only very scientifically interesting and useful, but it's also very aesthetically, it's very pretty seeing things like that. We